Hello, my name is Trupiano, and this is my individual research project presentation. I did my individual research project on social networks and analytics. This is for CSI5510, Advanced Website Design and Application at Oakland University. Brief overview, we're going to go over an introduction of the topic, a quick background and history, in-depth coverage of key components and techniques, and a research paper of focus, which is a privacy preservation techniques in big data analytics. So a brief introduction. So this presentation is going to focus on specifically the practice of social media analytics. The concept of social media analytics, we're going to deal with utilizing various frameworks and tools that deal in the realm of informatics and analytics in informatics. These tools are going to attempt to collect, monitor, analyze, summarize, and visualize social media data. This process is specifically motivated by business rules and requirements derived from those rules. So the question to ask is, what is a social network? A social network is defined as, quote, a network of interactions or relationships, where the nodes consist of actors and the edges consist of relationships or interactions between actors. Social media analytics is also about finding meaning and context in the data, which in turn will support business decisions. Social media analytics softwares, like the ones web search engines use like Google to get its work done, it uses stuff like that. This includes utilizing technology to analyze various web objects such as keywords, metadata, and tags. The steep increase in social media popularity can partially be attributed to analytics. A key part of analytics is the transfer of gathered and processed data to third-party affiliates by the social media companies to sell relevant advertisements to in turn get the users to spend more money. So that is one of the reasons social media is really rising, is because of that true relevance in social media because of these analytics. So this is just a brief overview of the process of social media analytics. We start with a set of unstructured text, right? This text is basically text gathered from social media posts and things like that. Now that unstructured text is going to be imported into a web database by a bot or a program that somebody writes. The data is then categorized and qualified. Then it is analyzed using various opinion mining techniques. And then insights are derived and then presented to the customer or the stakeholders. We're going to be getting into that in detail later. So you ask yourself, what is the purpose of social media analytics? Well, number one, it facilitates conversations and interactions between online communities. This is mainly achieved through the implementation of recommendation engines, which continuously study a user's transactions across the web to provide them relevant content and information that draws the users back to their sites to spend money. Right? One of the practices companies use to analyze data is through a concept called social listening. And it really means just monitoring social channels on social media like Twitter and Facebook pages and things like that for problems and opportunities that relate to their brand and their products. Another main purpose of social media analytics is extracting useful patterns and intelligence to serve business needs and fulfill requirements set by a business to gain useful insights on customer opinions and broad interactions. So here's a quote from IBM. News of a great product can spread like wildfire, and news about a bad product or a bad experience with the customer service rep can spread just as quickly. So in other words, social networks have changed the way information is published and spread and can really make or break a company's reputation. Some advantages of social media analytics. We're going to go over a few of these. So we're going to call it SMA from now on. SMA allows one to spot trends related to business offerings for services, brands, and goods. SMA also allows for a greater understanding of communication, specifically the intake and outtake of corporate messaging to their customers. How are these messages being taken in, and how do the customers in turn react to those communications on social media and other outlets? Okay, so some practical application for social media analytics. Social media analytics can be used in crime scenes, advertising and marketing, corporate public relations analysis. And finally, we have a quote here of another practical application. Machine learning techniques can be applied to data classification, organization, and analysis. Big data methods can also assist in managing and processing massive data volumes on social media. So now we're going to go over some in-depth coverage on the tools and techniques that social media analytics provides. The first facet of social media analytics will be opinion mining and sentiment analysis. But first we'll do opinion mining. So to start, social networks are useful sources of information for gaining insights on user opinions. But there's something missing. If you just have a bunch of social media data, there's no framework. Without that set framework, the data gathered is merely just a bunch of unindexed, unstructured text. So we do need a framework to gather all that text together. So opinion mining is a sub-discipline within data mining and computational linguistics. And opinion mining is used to extract, classify, understand, and assess opinions expressed in various online news sources, social media comments, and other user-generated content. So in other words, opinion mining can be used to extract the valuable context along with the identifying information from the users. And it can analyze the sentiment of the author's posts. And the different sentiments, usually in opinion analysis, are positive, negative, or a neutral tone. So companies can mine consumer opinions about product, services, and reputation by analyzing data from social media platforms. And finally, the gathered information would enable the company to manage sales, marketing, and business strategy more effectively and efficiently. Okay, opinion mining and sentiment analysis. So these two kind of go hand in hand, right? Opinion mining gathers context and understanding behind posted text and attempts to assess and classify that data into some meaningful thing we can analyze. Sentiment analysis is used in opinion mining to identify sentiment, affect, subjectivity, and emotional states in the relation to the people, events, and items/trends present in social networks. So sentiment analysis pertains to the specific analysis of the sentiment and emotional states of the people's posts. We're going to go over into some more examples of that later. So a strategy for opinion mining analytics. To properly compile and analyze information for context, a sufficient opinion mining strategy really needs to be in place here. The strategy must include aggregational techniques that perform queries and computations to compile, derive, and analyze context and sentiment from the social media data. This is going to include attitude of the authors specifically. Okay, so the paper Opinion Mining Methodology for Social Media Analytics is going to propose a very robust, detailed, and technically sound framework to highly utilize opinion analytics in social media analytics marketing. So we're going to go over this case study. We'll start with this flowchart graph. This is how their framework is going to work. First, we're going to do our data collection phase. That consists of web crawling, clipping, API, and sharing data from database to database between content providers. That's what third-party people usually do. Then we're going to move to natural language processing. That's where we're going to remove the garbage, which we're going to go over later. We're going to stem the document, feature, extract, and do a data type transformation. Once you do all of this, the data is considered qualified. Then it's going to be analyzed for topic and buzz analysis. It's going to classify different things into author ID, post subject, things like that. Then we're going to do a sentiment analysis, reputation analysis, and then statistical analysis. And then that's also being done using a lexicon approach to increase accuracy, which we're going to go over later as well. Finally, we're going to present it using graphs and tables and things like that. So we'll also go over that later. Okay, so to start with our phase one, which is data aggregation and collection. The objective here is connecting the social networks that you desire to gather data from. Access methods can vary, usually done by API if the social media network provides it, web scraping, and then things like that, and also web crawlers. Popular social networks usually provide easily accessible APIs to gather this data. An example with this is the Facebook Graph API. So let's say you were trying to gather interest to see if or what computer classes are popular in your locale, and you have a long-term goal of creating a large-scale computer class, basically corporation in your area. As a business, you could easily compose Python scripts using the Facebook Graph API to gather that data by using specific keywords such as computer class, in quotes, right? It is necessary to limit the amount of search results you gain to both keep the results accurate and to prevent too much data intake. So we will apply filtering in that regard. And just a quick note, you have to have a required token issued by Facebook's API to do this. So further expanding on the example from the last slide, you can extract information and make it human readable here. This researcher extracts the event ID first, and then from that unique ID, you can get a bunch of relevant fields such as attending count and can other guests invite. If part of the analytics methodology was to gain all information on the attendees of an event, use the request get in your Python script via the special URI. So you can see it's pinging the graph API, getting the event ID, and then getting a JSON file of all attendees. Okay, so let's say the social media network you're using does not provide an API. Well, it's going to be a little bit more difficult, but you can still gather data. You'll use something called a web crawler. These are search engine bots that traverse the web to search, gather, and compile information from websites into sitemaps. Okay, so phase number 2. Our objective for phase number 2 is using AI and language processing to qualify the data that was collected in the previous phase in order to obtain context. So the first part of data qualification is garbage collection. This is a crucial process. So garbage is constituted as any posts related to a search query that contain advertisements, emojis, unrelated content to the topic at hand that can skew your data sample results. Data collected always needs to be analyzed for garbage. Otherwise, insights will be rendered not useful if you have garbage in them because the results just aren't realistic. In a case study of movie tickets and tweets, this study was mainly concerned with removing garbage by determining which tweets were advertisements, which was determined by checking whether the tweet had a URL, as well as if the tweet had irrelevant keywords. This type of analytics during the data gathering phase is important to ensure the data is accurate and not skewed by the data that does not belong. Okay, so after the garbage is removed from the data, the next step is natural language processing. NLP, which is natural language processing, is a core aspect of language analysis. Natural language processing is used in social networking analytics to pre-process the data gathered in the data collection phase. These activities, according to the research paper mentioned earlier, include extracting features, tagging specific characters, parsing out sentences, and similar tasks like that, similar data filtering tasks are performed. After this pre-processing, it is now time for additional garbage collection and removal. You're going to be removing punctuation, emoticons, stop words. And stop words are really constituted as punctuation and emoticons. Stop words aren't really conducive to the language processing and need to be removed for greater accuracy. Okay, so once NLP has been run, data can now be stored in a structured or relational data format. Inside this structured, content-rich format, we can view important information such as the author name, content identification, reviews, counts, favorites, follows, created date, and things like that. For example, in this case study, this person used the R programming language to extract text from posts on Twitter via Twitter's built-in REST API. Users can use the R structure to obtain data from tweets, which are categorized into fields, such as username, hashtags, tweet text, replies, and favorites. So using R, the social media content extracted can be in the form of a list, matrix, and vector. To improve the mining accuracy when gathering opinions, sentiment dictionaries and stop words mentioned above can be generated as indexes to increase this performance. Okay, moving on to data analysis. So the objective of data analysis is applying opinion mining analytics to the data that was analyzed and qualified in the previous step. So qualified data sets containing user identification data tied with information from the content generated by those users is ready for application mining to gain insight on the business, the needs, and the market itself. The type of analytics applied to the data sets depend entirely on the purpose of the analytics in the first place. So let's say the analytics purpose is to analyze market trends. Then we're going to be using topic extraction and buzz analysis. However, if the purpose of the analytics are being performed to, let's say, establish insight on customers' responses to marketing activities, let's say related to a new product that just came out, then we're going to use sentiment analysis to kind of gain an insight of what their attitude looks like. Okay, so again, as stated previously, to increase accuracy in both data qualification and data analysis, it is necessary to use semantic dictionaries and lexicons. For example, this is awful. Those quotes would correlate in a dictionary to a negative connotation. According to the same research paper about opinion mining, for example, after sentiment analysis is performed, its results can be categorized into various domain-specific lexicons by business case. This provides a detailed picture regarding whether the gathered analytical insights are positive or negative. We're going to touch on this again in just a little bit. So we have our data presentation phase. This is the most important part of the project. If you cannot present your data to the stakeholders, the analytics are useless because no one will understand what's going on. So presenting the data in a matrix table or graph that's easy to understand is extremely important. Okay, so now we're going to look at a case study in this paper. So Y. Kim and S.R. Jung conducted a study of SY Food Corporation, and that's an instant noodle company in Korea, and they wanted to show how social networking analytics are applied in a practical setting. They collected 14,204 social media posts, which consisted of mainly foreign messages and blog posts and other things like that. The data types were collected that were mainly text strings, author names, unique IDs, kinds of things like that. Together, the social media data, since there were no robust APIs available like Facebook and Twitter have, the researchers actually deployed web crawlers like we talked about in the beginning, which used keywords, specifically those with the SY brand name. So one of the keywords they used was SY ramen. Okay, so after data is collected, it is inputted into a table and analyzed for volume of traffic from the various social networking platforms. The qualified analytical raw data is now applied into topic extraction and sentiment analysis, both of those. And after the opinion mining is complete, the results then need to be compiled into an easy human-readable format, like you can see in Table 2 below. So here is the data presentation. So we can see in this graph, it shows the overall sentiment values of the analyzed social media users. You can see that most of the values are positive because it's over that red baseline. The ones that are negative are circled in red. And so really the range for the score is anything below -1, -1 and below is negative, 0 is neutral, anything above 0 is positive. Okay, so here is our research paper of focus. It's Privacy Preservation Techniques in Big Data Analytics, a survey. So brief introduction. While all of the insight gained through social media analytics is very useful, it also comes at a cost to the user. As we move into the present day, users are becoming increasingly worried about privacy, and really a lot has changed in the field of social media analytics, especially with regards to privacy. A Pew Research survey conducted in 2014 actually showed that 91% of Americans either agree or strongly agree that people have lost control over how personal information is collected and used by all kinds of entities. And it's only getting worse because social media analytics are becoming more accessible and becoming more easy to use and ramping up in terms of usage. Furthermore, according to Pew Research, quote, some 80% of social media users said they were concerned about advertisers and businesses accessing the data they share on social media platforms. So it's a growing field, and the sophisticated APIs are becoming easier and more accessible to use, so that means it's only going to ramp up. According to Mordor Intelligence, the market for social media analytics is valued at $7.26 billion in 2020. By 2026, they're predicting that number to grow to $25.96 billion. So not only is the field becoming more accessible, it's also becoming more valuable. So it's only going to the amount of social media analytics that are going to be performed are only going to go up. The value of the user's data has grown exponentially, and with that growth has become an increased sense of privacy among our users. So we're going to ask this fundamental question: how do we preserve individual privacy while still maintaining the usefulness and utility of the data gathered? That is a very huge trade-off that most companies do not make. They just want the data. So what are the key objectives of the paper? The paper analyzes the current situation when it comes to social networks and e-commerce and other applications and services that utilize big data analytics to function. The paper aims to identify vulnerabilities of web analytics when it comes to user privacy. The paper also outlines both the strengths and weaknesses of various privacy protection and prevention solutions and models. The paper also proposes a data lake-based modernistic privacy preservation technique to handle privacy preservation in unstructured data, and we're going to get to that in a little bit. Okay, so one of the key takeaways is this quote: data analytics will affect data privacy. So your privacy is affected anytime your activity is being surveilled and used to generate revenue across the internet. According to the research, a mere 17% of smartphone users fully understand the impact of privacy vulnerabilities. Recommendation engines are one of the most popular implementations of data analytics, especially on social networks like Facebook. These engines are responsible for gathering, analyzing, and displaying relevant advertising and product recommendations based on your browsing history. Based on your browsing history across the internet, Facebook uses analytical technologies that we outlined earlier to recommend places to visit and product recommendations, service recommendations, and things like that. If data is left in the public domain, which most of it is publicly accessible, by definition is a privacy threat to the individual posting it. This is because the data is not owned solely by that user. It is owned by the place the data is hosted on. And opinion mining can occur through the sanctioned and unsanctioned use of web scraping APIs. Data ownership is key here. So the paper identifies 4 core privacy threat areas: surveillance, disclosure, discrimination, and personal embarrassment and abuse. The one that most pertains to our use case is social networks and analytics is going to be surveillance. So most social networks and e-commerce platforms continuously study customers' purchasing habits and patterns. After processing this data using the analytical models that we discussed previously, they then recommend relevant value-added services and advertisements to the customer in hopes that they'll spend money. In particular, the paper identifies social networks as utilizing sentiment analysis and opinion mining to provide recommendations, such as following a public figure or to like a corporation, establishments or locations to patronize, and things like that. According to the paper, the only possible way to provide accurate and relevant recommendations is by the continuous surveillance of their users and their web transactions, not only on their platform, but across the internet. Okay, so the paper outlines several privacy preservation techniques. One of them is k-anonymity. In this one, data is modified, leading to k-indistinguishable records if one attempts to map the de-identified data using unique identifiers. Randomization adds extra noise data based on the probability curve to kind of skew the results and stop data from being uniquely identified. Then we have vertical and horizontal data distribution. In vertical data distribution, individual specific data is distributed across multiple systems by different system owners. An example of that would be if a police officer wanted to obtain data on a felon, they might be able to get their address and phone number through the police department, but they might have to go to a different system to get employment information, prior arrests, and things like that. Horizontal data distribution. Data is stored on different sites with common attributes for aggregate querying. For example, a store could distribute sales records for their branches in different physical branches on different databases. And aggregate functions can be used to gather like information between all of those things. Cryptography. Data is encrypted before the public analysis. The data is generalized so aggregate functions can be applied, and the results do not contain uniquely identifying information. The best method identified is multi-dimensional sensitivity-based anonymization. This uses the Apache map framework with the Hadoop file system, and processing large data sets with less loss is much easier, and it uses predefined quasi-identifiers. Because of the scope of this project, we're not going to go too much into that one. So previous methods only deal with structured data that we talked about before. That's data that's already been taken in and already analyzed, already garbage collected, and things like that. According to the paper, 80% of data gathered for analytics is unstructured. This data specifically needs attention, and this is what this project hopes to resolve. So the goal here is to maximize social media data utility along with data privacy. There's no point in analyzing data if we can't gain meaningful insights. But if we completely neglect the privacy aspect, we are going to cause the users harm. So here is a proposed privacy preservation model by this paper. The paper is using Data Lake, which is a repository for data holding in a raw format. In this model, the data consumption from social media platforms is going to be performed by Apache Flume into the Data Lake repository using social media analytics. So in this model, we have the data consumption being scraped from social media platforms using Apache Flume. That's going to load the social media data into the Data Lake repository. The structured and unstructured data can be ingested in the Data Lake at the same time. There's no need to do it separately. Data is then processed and transformed into Hive tables. After that, the data is then passed to a Hadoop map reduce job. And this is also paired with a machine learning algorithm, which is going to identify and classify and skew sensitive information so it can't be detected when it's being analyzed by analytics. Finally, data can be vertically distributed. Sensitive data can be separated and tokenized for mapping purposes from the rest of the data. This is part of the novel privacy preservation algorithm. This removes sensitive attributes from the data, allowing it to be publicly exposed for business case analysis without giving up any uniquely identifying information. So some key insights on the paper. So here are some paper strengths. The paper identified a unique need. The fact that there is no solid solution for protecting privacy when analyzing unstructured data really needs to be addressed. The paper also comprehensively analyzed and compared the popular measures for privacy prevention, as well as analyzed the important vulnerabilities that exist in social media and e-commerce tracking and analytics practices today. This paper really did a good job of showing the harm to the user. So before this, you really didn't know how much harm you were getting into, but after you read the paper, you really got a good idea of what the harm is to the user and how that all works. Moving on to some paper weaknesses. While the theoretical models were presented very, very well, these all lie on the shoulders of web developers to implement. The solutions are unreachable by normal end users. I believe it would have been beneficial for the paper to include some measures that the end user can take to preserve their privacy while using social networks that they can easily set up. For example, I did some Google searching and found this website called advertiserblocklist.com, and they list various extensions and workarounds that end users can use to install and prevent social media sites from tracking their activity across the internet. Various suggestions include mainly browser extensions that block tracking and analytics from taking place. For example, they have a Twitter disconnect extension, Facebook tracking pixel extension, and blocking Google Analytics tracking extension, and much more. I believe including this would be able to educate end users better if an end user were to be reading this, and maybe give them some insight as opposed to a high-level theoretical implementation that hasn't been proven out yet on a large scale. Okay, so this concludes my presentation on social media analytics and social networks. If you have any questions, feel free to email me, strupiano@oakland.edu. Thank you very much and have a great day.